Alright, today in class we discussed function notation and evaluating functions. And just a real quick review and kind of summary of why we use function notation. Right here we have I have a graph drawn of a line. This line has an equation y equals 2x plus 2. You don't need to know where I got that, but y-intercept is 2, and it does go up 2 over 1 for a slope. But this equation is clearly a function because if we look at the graph, it passes the vertical line test. And because it's a function, we can use what we call functional notation when we write the equation. Okay, and that's exactly what this section is called. So we can use function notation, and function notation just looks like this. It says if you have a function which this equation or this relation, because it gives us ordered pairs, is, if you have a function, you can give it a name like f. You can state what the variable is in terms, what the expression is in terms of for a variable, and then you write the expression. So these two, this equation and this equation written as function notation, mean exactly the same thing. F of x and y are interchangeable, but by using the f of x notation, it tells the user and the person working on the problem that, hey, this is not just an equation, it is a specific type of equation, it is a function. And that means that every x you plug in will give you only one answer out, because that's what functions do. So that's what function notation looks like, f of x. And of course, I named this function f of x because function starts with the letter f, but I could have called it g of x. I could have called it, maybe I wasn't using x's and y's, maybe on the x-axis was time and the y-axis was e for elevation. And then this equation will give me the elevation as a function of time equals 2t plus 2. So notice two things changed. I changed it to function e, and my variable in the parentheses, I put a t there because that's what's acting as my x in this case. Okay, and that variable inside the parentheses should match the variable inside the actual equation or the function. Okay, so that is function notation essentially. Now, once we kind of understand what's going on, I'm going to write a new function here, 5x minus 3. This is very usable notation. For example, let's say I want to know what happens when x is 2. Okay, normally I'd have the equation y equals 5x minus 3. I'd say, hey, what is y when x is 2? And I'd have to plug a 2 in there for x. In functional notation, we can ask the same question, but we ask it differently. We just say, what's the f, the value of function f, when x is 2? That's what that means. So it says, we read that as the f of 2, and to find the f of 2, we just go equals, and we steal what the function is. It no longer has an x inside the parentheses, it's now a 2, so x gets replaced with a 2, and the f of 2 is 10 minus 3, or 7. Okay. I'll do one more of those things. This time let's have a function g. Let's say g of x is x squared minus 5, and I would like to find the g of negative 3. So I grab function g, and it says take whatever x is, in this case negative 3, square it, and subtract 5. So I square negative 3, negative 3 times negative 3 is 9, and I subtract my 5. G of negative 3 is 4, or equals 4. Note how you say that. G of negative 3 equals 4. And we can even get fancy with this notation. Here's another function, f of x equals 2x plus 3. And let's say instead of plugging in a number for x, I want to plug in a variable or an expression. I want the f of 4x plus 2. Well, I do the same thing I did before. I go up to function f and I go 2, and I replace the x with what I'm trying to evaluate it at. Change back to red for that parenthesis. Okay, so the x gets replaced with 4x plus 2, and I end up with, distributing the 2, 8x plus 4 plus 3, or 8x plus 7. And notice how I work it. I never touch the left-hand side. The left-hand side, f of 4x plus 2, I just follow the equal signs down, is 8x plus 7. And then our last example, I'll do this one a little bit differently. Maybe I've got x squared minus 1. And let's say I want the g of a plus 2. Okay? So I replace the x with a plus 2. Then it says square whatever you plugged in and subtract 1. Okay? Then we always want to clean this thing up if we can. So a plus 2, if I square it, means to take it times itself. So it looks like this now. And then this is a big distributing problem. I'll leave it to you to do all the distributing, but the answer, when you multiply it out, is that. And then I can do 4 minus 1. So there is the g of a plus 2. And your homework's at macintosh.net. Just go to Algebra 2 Notes and Assignments, and this is lesson number 2 on functional notation.